Okay, so today we will be talking about Unit 3, that is inverse of matrices. I'm just sharing, yeah. Now you can see the screen. You can see my slide now. Is that visible to you?
Yes, yes.
You can see the slide now. Okay. That is inverse of matrices. As far as the definition of inverse of matrix is concerned, the inverse of a square, that is n by m matrix A, is another n by n matrix denoted by A inverse, such that A into A inverse is equal to A inverse into A is equal to identity matrix. We have seen identity matrix in our previous session. It has to be of the same order as of the parent matrix is. Multiplying a matrix by its inverse produces an identity matrix. Note, however, that not all the square matrices have an inverse matrix. Now the question arises why? If the determinant of the matrix is 0, then it will not have an inverse. Since matrix whose determinant is 0 is known as a singular, we stimulate the condition that only a non-singular matrix will have an inverse. Such a matrix is also called as invertible matrix. Now we will see how that is performed. What are the properties of the inverse matrix? A square matrix is invertible only if and only it is not a singular. The inverse of a matrix is itself the original matrix. The inverse of transpose is denoted by A hyphen at the top. Yeah, A T is same as the transpose of its inverse. That means you can see that A transpose inverse is equal to A inverse transpose. If A and B are two invertible matrices of the same order, then AB is also invertible, which holds true for AB inverse is equal to B inverse into A inverse. You can check it by taking two matrices and apply these conditions on that. Now, how the computation of the inverse is done using adjoint of a matrix. We will see that if A be a square matrix of order n and a square matrix B of order n is also called the inverse of matrix A if A into B is equal to B into A is equal to identity. Or we can say that this is the formula what we will be doing. A inverse is equal to adjoint of A upon mod of A. Yani कि that is the determinant value. Only non-singular matrices are invertible. That means we can find inverse of those matrices only where this is a number not zero. Now we will see. Suppose we have to find the inverse of this matrix. Matrix is 1 minus 2 3, 3 minus 1 4, 2 1 minus 2. First of all, we have to find the inverse and then we have to show that. You can see that. What I told you, by taking one example, you can prove it. Initially, we have to determine the determinant of this matrix. This is determinant of the matrix. It's calculated like, if you remember it, you will start with 1. 1 is over here. Multiply these two numbers minus multiplication of these two numbers. This is 2 minus 4. First one is plus, second one is minus. Since minus is over here, this will become plus 2. Remove this, remove this. You will be left with minus 6, minus 8. Here it is. The third one is plus 1, plus 3 into, remove this, multiply 3 into 1, minus, since this is minus, so it will be plus. 1 into 2, that will be 3 plus 2. Now you are left with minus 15. Minus 15 is not 0. Therefore, X inverse exists. Now, first step is to calculate the adjoint. Now what we will be doing? We will be finding that minus. You can see over here, the calculation has been done. Here, A11, A1, A1. You will remove this. You are left with this part. We will be multiplying these two minus multiplication of these two. So this will be 2 minus 4. It will be minus 2. Correct? It's here. 1, 2. Remove this. Remove this. You are left with 3, 4, 2, minus 2. When you will be multiplying 3 by minus 2, you will be getting minus 6. Minus 4 into 2 is minus 8. Here it is. It will be minus 14. Third one, 1, 3. Remove this, remove this. You are left with this part. 3 into 1, 3. Minus into minus plus, plus 1 into 2 is 2. That is 3 plus 2. That will become 5. You can see over here, that is 5. First part has been solved. Now we will move to A21. Second row, first column. We will be eliminating second row, first column. So we will be left with minus 2, 3, 1, minus 2. We will be multiplying minus 2 into minus 2, that will become 4. Minus 3 into 1, 3. You can see over it is here, 4 minus 3. Similarly, we will be doing for all the 6 elements, and we will be getting these. Now, if you remember, you have to check the sign. We are finding out the cofactors. We will be adding this. 1 and 1 is 2. 2 is an even number. If we get an even number on summation of these, we will not change the sign. This will be minus 2. Third one, second one is 1 plus 2 is 3. We got minus 14, so we have to change the sign. It will become plus 14. Similarly, 1 plus 3 is 4. We won't change the sign. Alternately, we will change all these signs. Correct? Now, see to it how adjoint is written. Adjoint is transpose of this form. We will copy all these numbers from here. We will place them in this order. Then we will find the transpose. That means rows will be converted to columns. So that means this minus 2 will remain here only. And 14 will come down. 5 will come down over here. So this will be removing like this way. So similarly, minus 1 will be here. A minus 8 will remain over here. And this minus 5 will come here. And this minus 5 will come over here. 5 will here and 5 over here. Correct. Now, this is the transpose. First of all, we have to find the determinant value. We have to see it should not be 0. If it is not 0, proceed further. Find out the cofactors. Cofactors are placed in this form, and after that the transpose is evaluated. Transpose will be converting rows into columns. So this is your transpose, but basically that is the adjoint. Now we have the formula of inverse. A inverse is equal to adjoint of A into mod of A. We have key and we have this. Correct. So this is the A inverse of this matrix. Now going back to the problem. What was the problem? It was asking to find A into A inverse is equal to A inverse into A is equal to identity 3. Identity 3 means it will be a matrix. It will be an identity matrix of order 3 by 3. Now we will see A into A inverse. A into A inverse. So we will be taking this away and we will be multiplying these two. Now if you remember, multiplication is always done from left to right, top to bottom. 2, 1 into minus 2, minus 2 into 14, plus 3 into 5. You can see these numbers are written over here. Similarly, for this to this, 1 into minus 1, plus minus 2 into minus 8 is 16, plus 3 into minus 5 is minus 15. Second one. Third one, this and this. 1 into minus 5, minus 2 into 5, and 3 into 5. Here it is. Similarly, we will be following with the second row, first column, second row, first column. Minus 6, minus 14, minus 20. Similarly, second row, second column. Minus 3, plus 8, minus 20. Third one, second row, third column. Minus 15, minus 5, plus 20. Here it is. With third row, first column. Minus 4, 14, minus 10. Minus 2, 8, 10. Here it is. Minus 10, plus 5, minus 10. Here it is. So you will be getting this one. As soon as you will take minus 15 out, this will be converted to 15 by 15. Minus into minus will get plus, and you will be left with identity 1, 1, 1 along the diagonal. This is identity matrix of order 3. Similarly, we can reshift it and we will get the same answer. So this is how the inverse is calculated, and you can prove that A into A inverse is equal to A inverse into A is equal to identity matrix of order 3. Any doubt in it? How the multiplication is, but that is the most important part. Multiplication of two matrices. Any question, any doubt from anyone? Is
No,
that
I
clear,
know.
or I should?
Yes,
So
it's
that
clear.
means I can proceed now. Now,
Yes,
to
yes,
find the matrix, inverse method, that is we will be finding the inverse by elementary operation method. What we will be doing? What is the exact step? You have to find the inverse of this matrix. What is, you can see over here, it is this matrix. Okay, fine. Write it like this way. Okay. Again, write this matrix is equal to identity matrix of order 3 into A. Now, what we have to do, listen to it very carefully. This is the original matrix. In this matrix, we have to convert this matrix into an identity matrix. Number one. Number two, whatever the operations you will be doing in this matrix in converting it into an identity matrix, same method, same operations will be performed in this matrix. Okay? These are the two things which have to be remembered. First one, this matrix has to be converted into an identity matrix, and whatever the operations you will be performing in this, the same will be performed over here. Fine. So we will start with this. If we have to convert this into an identity matrix, so first of all we have to make this as zero, and this will remain zero. We don't have to do any transformation in that. So for making this into zero, what we will be doing, this is has to be written. Don't forget it to write. Apply R2 tends to R2 plus R1. This you will be applying over here. So when you will be adding minus 1 plus 1, it will become 0. You will be adding these two, this will become 5, and you will be adding these two, this will become minus 2. Correct? Similarly, what will happen over here? Same operation has to be done. R2 plus R1. R2 plus R1, this is your parent. R1 plus R2 will become 1. R2 plus R1 will become 1. And 0 plus 0 will remain 0. Now you can see you have achieved this part. Now, second part is how to make this as 0. For making this 0, or you can make this diagonal. There are different methods of doing it. You can make this as 0 or this as 1, because diagonal you have to convert by 1 by 5 or multiplying by 1 by 5. So this will be 1, this will become minus 2 by 5, this will become 1 by 5, this will become 1 by 5, and this will remain 0. Now you can see this is this. In the diagonal you have 0, diagonal you have 1. The maximum problem has been solved. Now what to do in the remaining one? As far as the remaining part is concerned, so we have to make this part as 0. We will be taking the help of second one. So what we will be doing, we will be transforming R1 tends to R1 minus 2 times of R2. When we will be performing this, so this will be 1. Only the change will be in the row 1. When you will be adding this, so no change will be there, it will remain 1. When you will be subtracting 2 minus 2, it will be 0. Here it comes, minus 2. That will be in the C over here. What is happening? This minus 2 times of 2 by 5. So that will be minus 6 by 5. Correct? Now you are having, now see, this has been transformed to 1, 0, minus 6 by 5. Remaining all the elements will remain same in this matrix. And the same operation will be performed in these two parts. because we will be using over here 1 minus 2 by 5. That will be 3 by 5. And minus 2 by 5, this is minus 2 by 5. This will remain 0. Now you can see that there are some changes in this, and these elements have been reduced. Moving further, this is your parent, what we have done here. Now what to do? We have to make this 0. So for making this 0, we have to apply R3 tends to R3 plus R1. But how is hmm, row 3 tends to row 3 plus row 1? Hmm, Go to the previous slide. Okay, we are adding R3 to R1. Okay, add it. Okay. R3 tends to R3 plus R1. We will be performing over here, and then we will be applying R3 tends to 5 times of R3. So this will become, now we are much worried about this part. This two columns have been converted. Now this has to be converted to 0 and 0. What we will be doing? We will be doing row 3 R1 tends to R1 plus 6 by 5 R3. And simultaneously, we will be doing the same operation with R2. That is R2 plus 2 by 5 R3. So you can see that as soon as that operation is performed, this will be reduced to 0 by 0. And here you will get this. Whatever you get over here, if you remember, I told you A into A inverse is equal to identity matrix, or A inverse into A is an identity matrix. So that means this is your inverse. This is identity of order 3. This is your original matrix A when it is multiplied by any matrix, and the product is equal to identity matrix. This matrix is the inverse. Straight away you can write this is the inverse. Okay, so we have found inverse by two methods. First is by the formula A inverse is equal to adjoint A upon determinant of A, and secondly, this is by row transformation. Now, we will be moving to unit 4. Is the slide visible to you?
Yes, yes.
Okay, now that is unit 4 application of what we have learned till now. That is how the problem will be converted into a matrix and how it will be used to calculate what we exactly want to do. The application of matrices in business and economics. We will discuss the application and use of matrices for business and economic in decision making. Here, what we will be doing, we will be discussing about the applications of matrices in matrix representation of data, market demand and supply equilibrium, national income model, and input-output analysis. This is what we will be doing. Now, the thing is that how to convert the data into matrix representation. Suppose this is the problem. A firm has three factories, F1, F2, F3, and four warehouses, W1, W2, W3. It wants to find the minimum per unit transport cost from each factory to each warehouse. We have been given the cost data in matrix form in the following and find the minimum as well as the maximum unit cost for each factory to transport its product to warehouse. Now you see that this data is given to us. These are the warehouses and these are the factories and these are the units which are transported. And we have to find the minimum as well as the maximum unit cost of each factory to transport its product to warehouse. That means if we have to calculate the cost, that means we should have two data with us, number of units and the amount. That is the cost per unit. So what we will be doing, this is basically we have to what we are supposed to find. We have to find the per unit cost is minimum for F1, F2, F3 to W4, W2, W4. Straight away we can see from the data what is given to us. And we have, and the second part says the per unit maximum cost. F1 is F1, F2, and F3 to W3 and W1 and W2. This is what we can see from the data. Data has been converted into a matrix form. That means from three factories to four warehouses. Now we have to convert this information into a matrix form. Now see, in an introduction contest, a participant can speak either of the five languages, that is Hindi, English, Punjabi, Gujarati, and Tamil. Fine. Our college, say number one, has 20 students, of which 10 offer to speak Hindi, 9 English, 6 Punjabi, and 3 Gujarati, and rest Tamil. So straight away, what can come our into mind? That is, we can write colleges on this side and the languages at the top. We have this and we have this. These are these number of colleges and these are the languages. Going back to the problem, we see that can offer to speak Hindi. Right from we are talking about college one. Straight away with the Hindi you can write and in front college one you can write it. In English there are nine. Below college one you can write nine. Now second what is happening in another college two, 25 students of which seven spoke Hindi. Right? Seven. Eight English. Eight English. 10 Punjabi. 10 Punjabi. How much it is? 25. The rest remaining will be zero. What about for three? First of all, it is division, second one is district, and the third one is taluka in a certain state in India. Assume that there are 5 divisions, 30 districts, and 200 talukas in the state. Each office has one head clerk, one cashier, one clerk, and one PM. This is related to the manpower. A division office as an in addition, an office superintendent, two clerks, one typist, and one PM. The district office has an addition, one clerk, one PM, but this is the manpower requirement or the manpower they have. Now, what are the basic monthly salaries of these people who are working in these offices? For office superintendent, it is 15,000. For head clerk, it is 12,000. For cashier, 11,750. For clerks, it is 11,500. Typist, 11,500. And for PMs, it is 7,500. Now, what is us from what we are supposed to do from this calculation? We have to use matrix notation and find the total number of posts of each kind of the office taken together. Number two, total basic monthly salary bill of each of kind of the office, and the total basic monthly salary bill of all the offices taken together. Now the thing is that what the problem states. We are talking about a state in India. That state has offices. That state has divisions. First division is of the first is division, second is district, and third is taluka. In these three, there are 5 divisions, 30 districts, and 200 talukas in the state. So what we will be doing? First of all, we have to arrange number of offices and which can be arranged in a row. You can see what is happening. Out this line, the statement is being converted. First of all, we have to identify division, district, talukas. That is 5 divisions, 30 districts, and 200 talukas. We have to come to the composition of the office. How many designation posts are there? Office superintendent, head clerk, cashier, typist, clerk, PM. Write it. Going back to the problem, this is what they have stated. Each office has one head clerk, one cashier, one clerk, one PM. We will keep this all one. Apart from that, this what they said. In addition, one clerk, one PM. One clerk and one PN is there in what is this 3 by 3 and 2? Office superintendent, typist, and PN. Office superintendent, typist, and PN. Okay. So this is the conversion. This is for the division, this is for the district, and the last one is for the taluka. Okay. The third matrix will be of their wages. Office superintendent, head clerk, cashier, typist, clerk, and PM. Okay. Now we have to find the total number of posts of each kind in all the offices are the columns of the matrix. So A we have to multiply A into B. This has to be multiplied A into B. So in that Now see to it, going referring back to the problem. How multiplication is done? Left to right, top to bottom. 5 into 1 is 5, 30 into 0 is 0, 200 into 0 is 0. You are having 5 over here. Secondly, move to this row into this column. 5 into 1, 30 plus 5, 30 into 1 and 200 into 1. That will be 235. This is 235. Similarly, we have 111, we will have 235. We have 1 only, that will be 5 only. Now, 5 into 3 is 15, 15 plus 60 plus 200. So this will become 275. And the last one will be 10 plus 60, 70, 70 plus 200 is 270. Correct? So this is about the total number of posts. Now we have to calculate the total basic monthly bill for each kind of office. It is the element B into D. This is into the salary. Okay, so you can see over here. There are three offices, three divisions. This is the salary. And if we have to, the last one was to find the total bill of the office is the element of the matrix. What was the initial combination of the offices? This was and the product of the matrix. So this will be the amount. A single amount will be there. Now see how the matrix multiplication has been converted into a normal applicable problem. Is that clear how this problem has been solved?
Yes. Yes, yes.
Multiplication and the conversion of this statement into a matrix form. That is the basic thing what we are supposed to understand. How the statement has been converted into a matrix form. This was your original statement and this has been converted into a matrix in this way. This is what has to be understood. Yeah, how this has been transformed. And after that, the multiplication. I told you multiplication will be performed in almost every question. So for that, you have to remember that multiplication is done by from left to right into top to bottom. You can see to over here. I'm just reminding you left to right, top to bottom. 5 into 1, 5 plus 30 into 0 plus 200 into 0. That will be 5. And I'm just straight away moving to the last part. This is 5 into 2, 10 plus 30 into 2, 60, 10 plus 60 is 70 plus 200 into 1, that is 270. This is how multiplication is performed. And for multiplication, keep that thing in mind. Two matrices will only be multiplied when the number of columns is equal to number of rows of the second matrix. Six columns. Here there are six rows. Now we move to second application, that is market demand and supply equilibrium. It is as the name is holding. There is a demand and supply. If demand and supply curves for car are given to you, D is equal to 600 minus 60, 100 minus 60, and your supply is 28 plus 3, where P is the price of the car. What is the quantity of car bought and sold at equilibrium? What we will do? If we talk about equilibrium, so straight away one thing comes, a position of equalness. What in economics, what are the two things which are to be equal? That is the demand and the supply. All economics is the game of demand and supply. So for quantity to be in equilibrium, we will be equating demand equal to supply. We have demand as 100 minus 6p and supply as 28 plus 3p. So we will be finding out the value of p. That is the price. That means this p comes out to be 8. Now we have calculated the equivalent price. We can solve for the equivalent quantity by simply substituting p is equal to 8 into the supply or the demand equation. When you are going to put p in the equation of supply, you are going to get 52. That means at equivalent price of 8, the equivalent quantity will be 52. That means if a particular price has been evaluated, then at that particular price, after substituting the value in the supply part, you can get the exact equivalent quantity, which is 52 in this problem. Now we take another example. There are two common commodity X and Y, market model given by demand equations. Dx, everything will be in terms of X and Y. Demand Y,
Sorry,
again,
teacher, your presentation, your presenting is off. We can see your screen.
you can't see the presentation.
Yes,
Okay.
now it's okay.
Got it? Thank you for reminding me. I was just concentrating on the topic. I was not concentrating on the screen. Now we can see that two commodities X and Y. Market model is given by demand equations. Dx is equal to 11 minus 2px plus py. And dy is equal to 8 plus px minus py. Similarly, if these are the demand equations, then two supply equations will be there. Supply x will be equal to 1 plus 3px, and supply y will be equal to s plus 3y, where dx and dy are the demand quantities of x and y. Sx and sy are the quantity supplied of x and y, and p and x, px and py are the price of the commodity. Now we have to find the equivalent prices and quantities. For that, for equilibrium condition for x, demand should be equal to supply will be equal to quantity. All three values will be equal, so we will be taking up the 2. 11 minus 2px plus py is equal to 1 plus 3px. Bring like terms to the one side and unlike the numerical number on the other side. The variables will be on the left side. After simplification, what you are going to get 5px minus py equal to 10. That is your equation number 1. Similarly, we again set the equivalent quantity for y. Here what we will be doing? dy is equal to dx is equal to dq. Putting up the values, 8 plus px minus py is equal to 6 plus px. Py. So what we will be getting over here, p minus 2py is this. So you have these equations. Now we have two equations. What we will be doing, we will be picking up the coefficient of equation number one. Coefficient of equation number one is 5. Second one will be minus 1. In equation will be minus 1 and 2. And you have of 5. The, the constant, 10 and 0. They have to be in the order in the problem case. Don't take the order of the numbers or the elements. Now we have to find the value of the x and y. Now, that is how we will be doing. PXPY of the minus 1. First of all, what we will be doing, we will be finding out the determinant value. Determinant value will be 9. 10 minus 1. Similarly, we have to find the adjoints. So we will get the adjoint as 5 minus 1 minus 1, 2. We have to convert that into adjoint of this will be this. A inverse will be equal to 1 by 9 into this matrix. Now we have to calculate this value. What we will do, we will be giving this A inverse into A. That is what we have got over at the constants. When you will be solving, you will be getting 2.42 and 2.22. That means your Px will be price of commodity X will be 2.42 and the price of the commodity Y will be 2.2 at the equilibrium position. This is similar to the method by which we found inverse. Here we are simply multiplying. Now after putting up these values in the quantity part, you will get Qx is equal to 8.3 and Qy equal to 8.23. This is the complete solution. First of all, to determine the price of the commodity at equilibrium and then the quantity at the equilibrium position. Now we will be talking about national income model. This is here we will consider a symbol to equation national income model for an economy involving
You are off?
Uh, I'm audible now.
Yes, yes.
There was some connectivity issue. So we were talking
Okay.
about national income. Here we consider a simple two equation national income model for an economy, ignoring government and trade relationship with external countries in the present analysis. Now we have two equations, y is equal to c plus I naught and c is equal to a plus b, where y is the national income, c is the consumption, I naught is the autonomous investment, and a and b are the constants. Now y is equal to c plus I naught. This one shows that the total value of the national income is seen from expenditure approach. That is, the total expenditure of the economy incurred on goods and services is equal to consumption expenditure and investment expenditure. That is why it is C plus I naught. When we talk about C, so here we can see that C is equal to A plus BY. This is something which is known as linear relationship between income and consumption. In the present context, A, the interceptor of the linear line, is assumed to be greater than zero, as it is generally postulated that consumption remains positive even when there is no income. The slope coefficient B is taken to be greater than zero but less than 1, as general psychological tendency of human being is to consume less than the total income, but you cannot spend more than what you earn. Now see, to compute the values of income and consumption of at equilibrium, what we will be doing, we will be bringing all the variables to one side and constant number on the other side of the equation. While we are solving the linear equations, we have to consider only the coefficients. So we will be picking the coefficient as 1 and coefficient of C will be minus 1. And coefficient of Y will be in the second equation, it will be minus B and the coefficient of C will be 1. This is basically the method how these problems are solved. What we will be doing. And on the right side, this matrix is I naught A. We want this value of Y and Z. That means we have to bring this over here. As soon as it is brought over here, it will be, we have to calculate the inverse of this matrix. And you know it how the matrix is calculated. When we will be multiplying these two matrices, that means inverse with these numbers, we will get the value of Y and C. Now here you will see how we get the value of Y and C. You have two equations, Y is equal to C plus I and C is equal to 5 plus 3 by 4y. And your I is 10. You have to find Y and C. Fine. Pick up, transform the ratio. Y is equal to C plus 10 and Y minus C is equal to 10 from this equation. And secondly, from the second equation, what is happening? Bring Y and C together on one side and the numerical constant on the other side. So what we are going to get? We are going to get minus 3 by 4 Y plus C equal to 5. Don't change the order of the variables. So this will be 1 minus 1 and minus 3 by 4, 1. This is your matrix. Second matrix is YC. The third matrix is the constant values, that is 10 and 5. Now, what we are supposed to do? We have to find the inverse of this. The inverse of this will be multiplied by 10 into 5. Then you are going to get the value of Y and C. And then your answer will be in a 2 by 1 matrix only. Now see, here what I've done, I've applied Cramer rule. Cramer rule was taught in the previous class. For finding y, we have to determine the values, um, determinant value of y and c. That will be divided by your this determinant of this value. For y, what I will be doing, I will be replacing these two numbers by 10 and 5. You can see this cell will replace by 10 and 5. This will remain same. No change will be there. And in the denominator, it will be 1 minus 3 by 4. That will be 1 by 4. Numerator, you are going to get 10 into 1, 10, minus into minus, plus 1 into 5 is 5. 10 plus 5 is 15. 15 divided by 1 by 4, that is 60. Here it comes 60. Similarly, in case of C, what we will be doing? We will be replacing this minus 1, 1 by 10 by 5. And this column will remain as it is. 1, 3 by 4 will be replaced by 10 by 4. After simplifying, you are going to get 1, 12.5, 12.5, 12.4 divided by 1 by 4, which is equal to y, it will be 60. This 4 will come up, 15 into 4 will be 60. That means your y is 60 and your c is 50. Now you might have understood how matrices multiplication or matrices application is. Now input output analysis. What in short we call it as IO analysis. Is another area where matrix application becomes in the aggregation of results. IO analysis is also known as industry analysis, as it explains the interdependence and interrelationship among various industries. For example, in a two-industry model, coal is an output for steel industry, though both the output age of the respective industries. What are assumptions in the economic part? The economy is divided into finite number of sectors on the basis of their assumptions.
You are off once again.
That was the problem today. Here, the thing is that what are the assumptions? The economy is divided into finite number of sectors, that is industry, on the basis of the following assumptions. Each industry produces only one homogeneous output. Production of each sector is subjected to constant returns to scale. Input requirement per unit of output in each sector remains fixed and constant. And the final demand of the commodity is given from outside the system. And the total amount of primary factors, that is labor, is also given. Now we will see how this is obtained. IO table shows the disposition of the total products and total inputs among the different industries. Let us assume that our economic consists of two producing sectors only. In addition, the production of each sector is being used as the input to all other sectors and used for final consumption. We suppose there are two X1 and X2 are the total outputs of two sectors. F1 and F2 are the amount of final demand, that is the consumption of output of these sectors. Xij will be the amount of output of the ith industry used up as an intermediary input for the jth industry. And L represents the given amount of primary factor. Here we will be talking about labor. And Li is the amount of primary factors used in the ith industry. Now this is how matrix is formed. We have two sectors, 1 and 2. Total output of the sector is X1, X2, and intermediate input requirement is from the different sectors, that is X11, X12, X21, and X22. Final output will be the final users will be F1 and F2. Now it is important to note that items in the above table are physical units per year. Since the entries in any row are all measured in the same physical units, there is no problem in undertaking additions across the rows. The total output column of each commodity and the overall input of the labor. However, items in the same column are not measured in the same unit. So it would be correct to add the columns down. Now, it may be seen from the above table that the requirements of the first industries are recorded in the third column. X1 units of output of industry was produced with the use of X11 units of first goods, X21 units of second goods, and L1 is the unit of labor. That means your final demand, that is the column 5, shows the commodity available for consumption. It is used that labor is not consumed directly. So after converting those into equation form, you will get x1 equal to x11 plus x12 plus f1. And secondly, you will get x2 equal to x21 plus x22 plus f2. And total labor will be L1 plus L2. Now, how to convert this into a matrix form? That will be xi is equal to summation of j equal to 1 to 2 terms because you have two columns, xij plus fi. And L will be ij is equal to 1 to 2 because we are talking about the two units. That will be xi. Then comes your Hawkins-Simon condition. In if the IO solution gives negative output, output cannot be of the product is used. up in the production of every one unit of that product. And it is not realistic and such a system is not viable. So your production cannot be met. How can Simon conditions guard against such eventualities? Now what is that? For our basic equation, x is equal to I minus A inverse into F, not to give negative numbers as a solution. We need to have matrix I minus A such that the determinant of the matrix must always be positive and the diagonal elements should be positive. In other words, element 1, 1 and A2, 2 should be less than 1. That means one unit of output of any sector should use not more than one unit of the own output. This is called Hawkins-Simon condition. Moreover, the first condition should be t greater than 0. That means determinant value should be greater than 0. A hospital C is a linear function of the number of inpatients I and outpatients P plus a fixed cost. That is the cost function. C is equal to given the following data of 3 days. Find the value of A, B, and D by setting up a system of linear equations using them the matrix inverse. Okay, fine. We have 3 by 3 condition. Now how that condition arises and how it will be written in the matrix form. First of all, the thing is that we have to substitute the values of C, or we have to calculate the values of C. Straight away move to putting up the values. You get A plus 10P plus 40I equal to 6950. Secondly, A plus 9P plus 35I is equal to 6722. And thirdly, it will be 12P plus 40I is equal to 7100. This is the conversion. Now you see you have three variables A, P, and I. Mhm. Ah, we will be converting into this. Now see, converting into matrix form. Take up the coefficients 1, 1, 1, 10, 9, 20, 12, 40, 35, 40. Variables are A, B, and C. And the product on the right side of the equation is 69, 50, 67, 25, and 7100. What we have to calculate? We have to calculate A into A inverse. A into A inverse is equal to no, we have to calculate the inverse. Okay. So first of all, we will be finding the mod of A. That means the determinant value of A, which will be minus 10. It's not equal to 0. We can proceed further to calculate its inverse. We have to calculate the adjoint. So this is the adjoint. You have to calculate the value of ABC. So it will be ABC is equal to A inverse into adjoint of into these constant values. So when we will be solving, we will be multiplying left to right, top to bottom. 60 into 6950 plus 9 into minus 80 plus minus 80 into 6725 plus 10 into 7100. After calculating all these things, you will get 5000 for A, 750 for B, and 300 for C. Now this multiplied by 10 is also to be done. We will be neglecting the negative sign. because they will not be negative. This comes out to be 500, 75, 30. Your A is 5,000, B is 75, and C is 30. In this, we have followed two things. We have calculated the inverse, and then the multiplication. Now we move to unit 5, that is mathematical functions. We will be talking about what function is, what does it provide, and what information we get, and how they are. A function relates an input or arrangement to the output. Notice the three main components, that is input, relation, and output, present in describing a function. For example, in producing an output, you have to use an input. It may also happen that you have got the output whose value is done. This means that the relationship between input and output is a simple function multiplied by 2. That means input into 2 is equal to output. If you use I for any other vector g to name a function, we normally use f. So you can see over, you might have seen these types of things. This is the function name, this is the input, and this is the output. That means this fx is a function of x. F is a function of x square. X square means it is a quadratic function. If the power variable has a power of 2, that is a quadratic function. Now functions and their types. Some important functions and applications in economics and business. What is the definition of function? A function relates each element of set with exactly one element of another set. In each element implies every element in set say X is related to some elements of another set Y. Secondly, except does not follow those two rules, then it is not a function, although it is still a relationship. In that event, the elements of both the sets are simply ordered pair, and they are called ordered pair because the input always comes first and the output second. Now see how they are related. Let the relation of x tends to x square is given by figure below. What you will be doing? First of all, you have to find the value of x and y. Your x states that it is a function of x square. So whatever the value of x you will be putting up in the function, you will get its square. When you put 3, you get 9. When you put 1, you get 1. You put 0, you get 0. But as soon as you place 4, you get 16, and even with minus 4, you get 16. This is in the relationship given above. Set x contains the elements of x, and set y has the elements of x square. It is a function as every element of x is related to y, and no element of x has two or more. Then comes your domain, codomain, and range. In the above example only, x is called the domain, y is called the codomain, and the set of elements that get pointed on in y is called the range. That means it is moving from The lowest one is 0 and the highest one is 16. That means its range will be from 0 to 16. And the function is given by x tends to x square. Now, what are the commonly used functions? Algebraic or transitive? If we talk about transitive algebraic, so they have polynomial. Polynomial can be constant, linear, quadratic, and they can also be rational price-wise. In tangential functions are exponential functions and logarithmic functions. Function types. First of all, we will start with algebra, but normally they are used. There is a group of functions called algebraic function where a function f(x) satisfies px f(x) equal to 0 as a polynomial in x and y with integer coefficients. These functions can be constructed using only a finite number of elementary operations, such as plus, minus, multiplication, and division. No other function will be used. First of all, polynomial function. A polynomial is the variable x, is a function that can be written in the form of f(x) equal to an x raised to the power n plus an minus 1 into x raised to the power n minus 1 till a2 x square plus a1 x plus a. That means from a particular positive value to 0. Now you see P1 is equal to 2x plus 5, P2 is equal to 2x cubed minus x plus 5, and P3 is equal to 2x squared, 2x3 minus 5x cubed plus 5x squared. Here the maximum power is 7. Power is always of the variable. Then comes a constant function. A constant function is a linear function for which the range does not change. So matter which member of the domain is used. Linear function. A linear function are those whose graph is a straight line. That means variable will have a maximum power of 1. And the equation is given by y is equal to fx is equal to a plus bx. Second one is quadratic function. A quadratic function is one of the form fx is equal to ax square plus bx plus c, where a, b, and c are the constants, and a is not equal to 0. If a becomes 0, so that will be converted into a linear function. Then comes power function. A power function is a function that can be represented in the form of fx is equal to kx is to the power p, where k and p are real numbers and k is also known as the coefficient. Then comes your rational number. A rational number is defined as a rational fraction, that is, algebraic fraction such that both the numerator and denominators are polynomial. That is anything in the form of p or q, where q is not equal to 0. That is a rational number. Then comes price-wise and we can find functions that behave differently depending upon the input value. That is, it must define the sequence of the interval. The absolute value function is given below as an expanded example for the Taylor function. Now you see, if you place minus 1 in a function, it will be multiplied by minus 1. It will be x into minus 1 minus x, subject to the condition that x should be, this will happen when the value will be less than, then comes 0. The function value will be 0. at 0, x is equal to 0, and the function value will be equal to x at all the values of greater than 0. Function type transitional. And I told you algebraic and the class of function is not possible as the infinite constraints of the algebraic operations of addition and subtraction, multiplication, division, raising to a power and extracting a root. Example of these types include a logarithmic and exponential function. Exponential function if a is any number such that a is greater than 0 and a is not equal to 1. Then we have an exponential function in the form of fx is equal to a raised to the power x, where a is called the base and x is called the can be in any real logarithmic function. It is normally denoted by y is equal to log x to the base 10. This 10 will be greater than 0 and b cannot be equal to 1. This gives the basic logarithmic function, which is real y equals the log x. As steps or b equals uh, the above function can be written as x is equal to b raised to the power y. Note that when no base is shown, the base is understood to be 10. Also note that the domain of the logarithmic function is the set of all positive real numbers and the range is all set of real. Log base 10 can be written as log base 10, which is known as slide is not visible to you.
Yes, yes.
It is visible.
No, it's not visible though.
Okay, fine. I can't see it on my screen. It's good if you can see to it. If log base e, that is log e, is used, it is known as natural logarithm and it is written as ln. If m and a be positive numbers, then important properties of logarithmic are
Dear sir, the slide is not visible for us.
now I'm making it visible to for you. Now it's visible.
Yeah, it's visible.
Okay. Now see how what are the properties of logarithm. Log first one log mn. That means these two numbers are in product. What we will be doing when we will be opening it. So it will be log m plus log n. Log of product is sum of logs. How to remember it? If it is divisible, divide if it is in division, m by n, it is log m minus log n. The logarithmic of quotient is the difference of logarithms. If this is log m raised to the power n, it will be n log n. Log of power of a number is the exponent times the logarithm of that number. Now you can see over here the basic four things. Log base e raised to the power x is x. Log base e to e is 1. Log base a to 1 is 0. And log a to a is 1. This is some minor things which have to be kept in mind. Then comes your inverse function. Inverse functions are defined as fx is equal to y if gy is equal to x. Or in other words, a function f has an inverse only if for every y in its range and there is only one value of x in its domain for which fx is equal to y. The inverse function is unique and is frequently denoted by f raised to the power minus 1, which is called as f inverse. I was using A inverse. For A inverse, what I was using? A raised to the power minus 1. That is representation. Now we are talking about functions, so f it will be f raised to the power minus 1. Now see, let the function f be the function with domain A, B, and C, and with codomain 1, 2, 3. Now we have to see f inverse. What is happening with f inverse? See the change. The reason is, see that f inverse is the inverse of f. The reason is element a map to 3 is f while 3 map to A is f inverse. Same is true for other elements. What is happening? See to it. Is there any change between these two? Can you find any change between these two? This is how the representation of inverse is made. Find the inverse function for fx equal to x upon x plus 1. Okay, fine. We will be assuming that let y is equal to x upon x plus 1 and solve for x in terms of y. Replace now you have to find the value of x. What we will be doing, y into x plus 1 is equal to x. Y is equal to x into 1 minus y. Your x will be equal to 1 up, y upon 1 minus y. That means f inverse x will be x upon 1 minus x, replacing x by y. Composite function. Composite function implies applying one function to the result of another. That is, the result of fx is sent through gx, and it is written as GOF fx, which means ffgx. If we have two functions fx and gx, then we can compose functions. Now how that is performed. Suppose your fx is 2x plus 3 and your gx is minus x squared plus 5. You are being asked to calculate fog of x. That means function of x. So what will be that? Your fog x will be equal to function of gx. Your function, where is the function? Function of gx is minus x square plus 5. So in equation 1, that is fx equal to 2x plus 3, replace x by minus x square plus 5 plus 3. So on simplification, you will get minus 2x square plus 13. This is the relation form of x. Functions with Cartesian coordinates. That means they will be plotted on graph. All the distances will be measured from 0. For a better understanding of the functional relationship between the variables, now let us return to the Cartesian coordinate system that is composed of horizontal lines and vertical lines, perpendicular drawn to each other. That means they are crossing it like this. Remember that these lines are called coordinate axes. The point where these lines are crossing the point where these lines intersect each other is called the point of origin. That is, so the point from vertical axis or y-axis is called the axis. You will see over here where these lines are crossing. It is 0. This part here along this and along this. Here x is positive, y is positive. Moving to the left, here x will be negative, y will be positive. Coming over here, x will be negative, y will be negative. And over here, what is happening? X is plus, y is. So this is your first quadrant, this is your second quadrant, third quadrant, fourth. Graph of some functions. If we talk about linear function will be is denoted by fx, and its graph will be a straight line. Absolute function. Absolute function is that function, whatever the value of x you take, you will get a positive answer. That means it is used to remove the negative sign. Positive will remain positive, and for the value of negative, its answer will be positive. In that case, its graph will be like V shape. Whatever the value of x you take, your answer will be a V. Is a twice function containing all constant pieces. The constant pieces are observed across the adjacent interval of the function as they change value from one interval to the next. The step function is discontinuous. That is not breaking over. Features of step functions are open circles and or closed circles on the graph. Open means point not on graph, and closed means point is on the graph. Will be in horizontal axis. This will be example represented. Fx is equal to minus 3, 0, 3. You can see the view line, horizontal view lines.
Yes.
These horizontal view lines. These are the steps.
Okay.
Okay, this is the representation of the type. Now comes your curvy types. Quadratic function. Quadratic function is a function in which the variable has a maximum power of 2. If you remember ax square plus bx plus c, this is a quadratic function.
Yes, I remember.
And that ax square plus bx plus c, when you will plot it on a piece of graph paper, you will find a U shape. You can see these two things. U shape, U shape graph. Now the thing is that what is the use of this quadratic function? This quadratic function helps us in describing demand, cost, revenue, and profit, which you will find while covering microeconomics analysis. The general technique for graphing quadratic is the same as for the graphing linear equations. However, since quadratic graphs are curvy, they are normally called parabolas rather than the straight lines generally by the linear equation. Your equation is fx is equal to ax squared plus bx plus c, where a is not equal to 0. When you will be plotting it, you will be getting. Now the thing is that depending upon keeping an eye on the coefficient of x square, you can determine whether the graph will move upwards or the graph will move downwards. If a is positive, it will be a straight U. And if A is negative, it will be an inverted U. Okay. The general formula for y is equal to x square is this parabola passing from origin. Whatever the value of x you are going to get, you will get the value. Suppose we get x, I replace x is equal to 1, I will be getting 1. For x1, I will be getting y1. X1, just moving here, y will be 1 here. So this is the point 1, 1. And if I'm putting x is equal to minus 1, again I'm going to get y equal to 1. So it will be on the other side. Because here minus 1 will be there and this will be 1. So you can see, if you are putting x is equal to 0, y is 0, this is the response. That means it is almost u. Now that is the point, how to find out the point where the graph is going to move. In that, the vertex is HK. Your equation is ax square plus bx plus c, where a is not equal to 0. So h is calculated by minus b by 2a. And k can be calculated by substituting the value of h in f. Then comes your cubic function. That means in that maximum power will be of 3. For cubic function, maximum power will be 3. So that general cubic function is ax cubed plus bx square plus cx plus e. Its graph will be something like this. If we take x is equal to x cubed, its graph will be something like this. This is basic functions related to business and economics. We will start with demand function. Demand is a function of price. For each price level of goods, there is a corresponding quantity demanded that consumers will demand. If P is the price per unit and X is the demand of the goods, then the demand will be a function of, where X is the demand variable and P is the independent variable. Here X and P are positive because negative prices and quantity are minimal. Normally there is a negative you are support. Then comes your supply function. Supply is a function of price. For each price level of goods, there is a corresponding quantity supplied to by the producer. If P is the price per unit and X is the supply for a good, then supply function is written as X is equal to G of P. P is the independent variable. Here X and P are positive because negative prices and quantity are minimal. Normally, there is a positive and linear relation between price and supply. Cost function. Total cost is the sum of fixed cost plus variable cost. Fixed cost is the sum of all the costs element, is independent of the level of output. For example, variable cost is dependent on the output, that means raw material, salaries of employees, workers, etc. Then comes your revenue function. Revenue is product of price and units, which is the relation between price of the commodity and output sold. That is, if X units of output are sold at price P, then the revenue will be Px. Profit function. Profit function is basically the difference between revenue minus the cost. If your revenue function is Rx and your cost function is Cx, then your profit function will be Rx minus Cx. But the point where revenue from sales is equal to the cost of production, that is the point, that point is known as break-even point. At that point, there is no profit. In other words, profit is equal to zero. That is, total revenue is equal to total cost. Now we will see to a mathematical problem. A businessman sells 2,000 units per month at a price of 10 each. It is estimated that monthly sales will increase by 250 items for each of rupees 0.25 reduction in price. See to it. Find the demand function corresponding to this estimate. Now the thing is that we have to apply ourselves. How to calculate the demand function? So first of all, we should be aware of what economics is all about, what has been given to us, and what we are being asked to calculate. If you see, going back to the problem, the estimate is increase of 250 units each time drops 0.25 from the original cost. Now, what is the original price? Please can. What is the 0.25? And this will be where you have to assume its price as well. It will be 10 minus b by 0.25. And 2,000 items is going to sell. So what I will be doing, I will be converting this in terms of p. That will be 2000 plus 10 minus p upon 0.25. So after conversion, we have to find we will be converting this in terms of x. The price will be in terms of that will be 12 minus x upon 1000. Secondly, a firm wants to launch a new product. It observes that the fixed cost of new product is 35,000 and the variable cost per unit is rupees 5. The revenue function of the new product is 500,000 x minus 100 x. You have to find the profit, break-even revenue, and the value of x results in loss. Now the thing is that whatever is given to you, convert it into the form of mathematical language. Your revenue function is there, it is noted by RX. Your cost function is given to you, fixed price is given to you, so that means your cost function will be the sum of fixed cost and variable cost. Fixed cost is 35,000. Variable cost, how much units you are producing? 500. 500 into X. Your profit function will be revenue minus cost. Okay? You have cost function and you have revenue function. Find out the profit function. That will be minus 100x square plus 4500x minus 35,000. For break even point, your revenue will be equal to Rx is equal to Rx is equal to Cs. You will be getting a quadratic equation. Split the middle term and find out the value of x. Now keep one thing in mind, your x can never be. If you get negative, neglect it. Here you are getting x is equal to 10 and x is equal to 35. For loss making values, that should be less than 0. After seeing this, you will see that if x is less than 10 and x is greater than 35, in that condition only, loss will occur. Because this function is related to your break-even. Break-even means no profit, no loss. If you are in loss, that means this will be negative. And this is negative only when x is less than 10 or x is greater than 35. You can see that all the three values have been evaluated. This is something related to limits and continuity, and we will be doing it in the next session. Okay,
Okay.
uh, you have understood today's part.
Yes, yes, very. It was a good.
Okay, so we will be meeting, I hope, next Wednesday. So we will be starting something more interesting, limits, continuity, and differentiation.
Okay. Okay.
Okay,
Okay. Yes,
bye
yes.
bye. Thank you.
Thank you. Thank you. Thank you. Bye.